Hi everyone and welcome to this tutorial session. In today's tutorial, we want to find all the solution of the equation a into cube root of a is equal to 1. Alright, so please follow the solution from the beginning to the end because every step of the way will bring good insight and explanation. Let's start. We have a into the cube root of a is equal to 1. To find all the solutions, we want to get all the values of a for which this left hand side will give us 1. All the values, both real values and complex values. Okay, so the first thing is to remove the cube root by carrying out the opposite operation. Okay, so let's watch carefully. Okay, let's write the expression again. A into cube root of a is equal to 1. We take the cube root of both sides. Of both sides. We cube both sides or raise both sides to the power 3. Now pay attention. Here we have a product raised to this power. All right, so we apply this law of indices, which says if I have this product raised to that power, the power will distribute itself. So I have a to the power n, b to the power n. This law will apply it here. This power will go on a, we'll have a cube. And that power will also go on the cube root of a, like that. All right, so that one here will have 1 cube, which is just 1. Remember, 1 raised to any power remains 1. Now this cube will cancel this cube root and we have a cube multiplied to a is equal to 1. A cube multiplied to a is going to give us a to the power 4 is equal to 1. All right, so what we have here is actually a quartic polynomial or a polynomial of degree 4. Okay, and so if we take this one from the right hand side to the left hand side, we're going to obtain a to the power 4 minus 1 equals to 0, giving us the quartic equation or the polynomial equation, polynomial of degree 4. It simply means that this equation is supposed to have four solutions or 4 roots. We don't come here at this level to come and say we take the full root of both sides. A to the power 4 equals 1, and then we'll say we take the full root of both sides, so that this fourth root and the power 4 will cancel to have the value 1. Well, this is just one of the solutions. If you do that at this level, if you got here and you do that, then you will end up having just one solution. You're supposed to have 4 solutions. So we avoid that unless we are asked to solve in the set of real numbers. All right, the set of real numbers, then this might give us part of the solution. But we still have to be very careful. So the best way is to take what we have on the right hand side, bring it to the left hand side to obtain a 0 on the right hand side, so that we see clearly the type of polynomial equation that we have to solve. This is a polynomial of degree 4, so we must have 4 solutions. Take note, not 1 solution. All right, looking at the left hand side, we have a to the power 4 minus 1. This is actually a difference of 2 squares. Okay, if we have been working, we will know that a to the power 4 can also be written as a squared. 1 can be written as 1 squared. All right, so that we see clearly a difference of 2 squares. Now, when we apply the difference of squares identity, we'll obtain a squared minus 1 into a squared plus 1 is equal to 0. When we apply the difference of squares identities here. Okay, now looking again at this first factor, a squared minus 1, it is a difference of squares. The same reasoning that we carried out here, we'll carry it out here. This one can be written as a squared minus 1 squared. All right, 1 squared is just 1, so we have not changed it, but we have written it in a way to see clearly that it is a difference of squares into a squared plus 1 equals 0. Again, here we apply the difference of squares identities to obtain a minus 1 into a plus 1 Then now this one, a squared plus 1 equals 0. We don't have sum of squares. There's no identity for sum of squares. All right, so now we have 1, 2, 3 factors multiplied together to give us 0. Again, if we have three things, a multiplied to b multiplied to c giving us 0, then either the first one is 0, or the second one is 0, or the third one is 0. That is always the case. So a minus 1 is like your a plus 1 is like your b, a squared plus 1 is like your c. Three things multiplied to give us 0. So we'll go ahead and I'll apply the same reasoning here. So we'll say either a minus 1 is 0. All right, if a minus 1 is 0, that simply means the value of a is 1. So a equals 1 is one of our solutions. We've gotten the first solution. 3 more to go. So we'll say, or this is our second expression, a plus 1 equals 0. If a plus 1 equals 0, we just simply take this plus 1 from the left hand side to the right hand side to obtain a equals negative 1. All right, this gives us our second solution. Right, we've gotten the first two solutions. They are all real numbers. So this equation actually has two real solutions already. All right, so we still have two solutions to get. Where do we get those two solutions? We get them here. This remaining factor, a squared plus 1, you see, it has the power 2. It's a polynomial of degree 2. Okay, so a polynomial of degree 2 will give us a quadratic equation from whence we can get the remaining two solutions. So we say a squared plus 1 equals 0. All right, so it's a quadratic expression in terms of a squared minus 1 equals 0. It's a quadratic expression in terms of a. Okay, so since it's a quadratic expression, let us collect our terms. The a is actually the coefficient of the squared term. The squared term here is a, the coefficient is 1. B is the term in a, there's no term in a. C is the constant. All right, so for me, if we use the quadratic formula in terms of a equals minus b plus minus the square root of b squared minus 4ac all over 2a. Not confusing this a with the a that we have there. All right, not confusing this a and the a that we have there. Okay, if we just let this to be x, then that will later on come and put so we just say let x be a in our equation. All right, so that we don't get things mixed up. All right, so we'll now have here x. Our expression is x squared plus 1 equals 0. So we'll have x equals negative b plus minus the root of b squared minus 4ac all over 2a. All right, we know that this x is actually a because our equation is in terms of a. All right, so now we'll put in our values carefully. Minus 0 plus minus the root of b squared again is 0 minus 4ac all over 2a. So this gives us root of negative 4 all over 2. All right, now what is the root of negative 4? Root of negative 4 is root of negative 1 times 4, which is root of negative 1 multiplied to root of 4. Root of negative 1 is I, and root of 4 is 2. So we have 2i. Root of negative 4 is 2i. So what then do we say? So there we're saying x is equal to, now in the place of root of negative 4, we're going to put 2i, all right, in this expression. So we're saying x is equal to negative, 2i all over, plus or negative, please. We've forgotten the plus or negative. This plus or negative 2i all over 2. These 2 cancels. So we're saying x is equal to plus or negative I. Okay, so we see we get the remaining two solutions. x equals plus or negative I. So finally, what are all our solutions? So we see solutions, all four solutions. We got them here, 1, 2, 3, 4. So we have x equals a, sorry, we'll come back to a, a equals 1, we have a equals negative 1, we have a equals positive I, and we have a equals negative I. So this gives us all four solutions to the equation a into cube root of a equals 1.